Hello, my name is Erica Sanchez, and today we will be performing a spectrophotometry simulation for my AP chemistry class. And you might be wondering to yourself what the purpose of this experiment is. So, the main goal of this experiment is to demonstrate how spectrophotometry can be used to effectively determine the concentration of a solution. By creating a calibration curve or an ideal graph from solutions of known concentrations and applying Beer's law, we can then accurately determine the concentration of an unknown sample. Before we begin, I'd just like to clarify what the Beer's law is. So, the Beer's law states that absorbance is directly proportional to the concentration of a solution. This meaning that more concentrated solutions absorb more light when compared to a less concentrated solution which absorbs less light. In this experiment, we will use stock blue 1 dye solutions to show that higher concentration tubes produced higher absorbance values, allowing us to later determine the unknown solution's concentration using the calibration curve. In this online experiment, we're provided with 3 different solutions, which include stock blue 1, distilled water, and an unknown drink or solution. And we can also see 6 different tubes that are supposed to be filled with different ratios of each solution. These include 10 over 0, 8 over 2, 6 over 4, 4 over 6, 2 over 8, 0 over 10, otherwise known as blank. And so we're gonna fill these up respectively. And the goal here is to make is to create solutions with known concentrations, which will help us to create the calibration curve later on. And now that we're done with that, we're going to start measuring the blink here on the spectrophotometer. 0, no, 0. And then dispense, rinse, waste. Oh. And we're going to repeat that with each solution. I'm going to measure each. Get rid of it in the waste bin. Rinse it off. Dump the excess. And keep on going. We're going to measure it. Repeat that process. Measure. Rinse. Dump. Then rinse. So I also took a notice of how as we move right, the lighter the solution gets because there's more distilled water in each tube, which will later play a crucial part in the graph. We're almost done. Measure. All right. Here we can see that the graph here plots absorbance on the y-axis and concentration on the x-axis, and that the data points form a straight linear trend which shows that the absorbance increases in direct proportion to the concentration. This relates back to the Beer's law that I mentioned earlier. To determine the absorbance, you can calculate it by converting the transmittance percentage that we were supposed to get here into a decimal, and then apply it to this rule here, negative log times t, to get these values, the values of absorbance. And with this information, we can also determine the slope of this line by just dividing absorbance over concentration. So for example, if we were to do solution 2, it would be 0.2363 divided by 1.848, which should give us the approximate slope of 0.1358. And now to measure the unknown drink. But before that, we're going to rinse it off. And we're just rinsing it off, and we're treating this as like a real life simulation or lab, because we don't want anything to cross contaminate in the real thing. So we're just taking our precautions here as well, even if it's not the real thing. And then we're measuring this, and we got 39% transmittance. And now we're going to apply the same rules that we applied before. We're going to convert this into a decimal, which would be 0.39, and then apply it to this rule, and you should get the value of 0.4089. And then to later find the concentration, you would apply it to the same equation. So it would be absorbance, which is this value, over over slope, which we determined before as 0.1358, to then get the concentration of an approximate value of 3.011. And then as the point is placed on the graph, we can clearly see that it's placed almost perfectly on the calibration curve we determined before, which once again proves the Beer's law. See, it's placed perfectly at the highest point over here. And then ultimately, the data table shows that the higher dye concentrations produced higher absorbance values. When these are plotted, the calibration curve forms a straight line confirming Beer's law. And with using the unknown absorbance value and equation here, I could determine its concentration.